Hello, everyone. Welcome to Cisco's Inside Product Podcast. Today, I have with me Guru Shenoy. Guru is our product leader for Hyperscalers, NeoClouds, sovereign clouds, service providers. It's a big job, my friend. Welcome.
Thank you, Jeetu. Yeah, pleasure to be here.
Yeah, and so we're going to talk a lot about what's happening in the industry with AI, with data center build-outs in these four kind of customer constituencies that you have, specifically in data center networking. Mm-hmm. And so walk us through what's happening, set the stage for us. Why is it important for what's happening specifically in service providers right now? Because that's actually a huge area of growth in addition to hyperscalers. And so what's happening over there, and why do you think it's seen a resurgence?
Yeah. Look, we are undergoing a massive transformation, as we know, with AI. And it's having major implications on traffic. And if you look at where the last 3 years or so have been, a lot of the energy around AI was around training, mainly the hyperscalers building big data center networks.
Right.
Now what we are starting to see...
Which we were involved in.
We've been heavily involved in that, helping those build-outs and investing in technology and so forth. But now we are starting to see sort of the consumption of AI, if you will, right? Inferencing, the agentic economy arising. And so enterprises, consumers are all starting to use AI. And so all of that AI is now starting to get delivered. Most of it is over telco networks, service provider networks. And so we are starting to see massive shifts in traffic, not just volume, but changes in the patterns of traffic. And so service providers, they both have they have a huge opportunity here because they are in the middle of this. They're the backbone of the AI ecosystem, as we like to say. And so delivering intelligent fabrics to serve these new AI workloads, participating more actively, offering potentially things like inferencing cloud. So there's huge opportunities for service providers, and that's what's causing a resurgence because, post 5G, this is the next big transformation, and this is a durable one that we see. So there's a lot of energy amongst the service provider community.
You don't believe this is a bubble which is going to go away at some point? Because
absolutely not. I'm 100% convinced that this is a durable trend because we are seeing value. We are seeing products and services that are actually adding a lot of value. That was hard to see in the 5G era. 5G was all about, hey, we need better latency, but no applications ever arose to fulfill that need, if you will. Yeah. But here it's a different ballgame altogether.
The demand had to follow the supply on that one, whereas over here the demand is almost instantly serviced as a result of the supply, and we are in a supply-constrained world right now.
Big time, yeah. We are not able to keep up just in terms of the infrastructure that needs to be built out to deliver all of these new capabilities that the agentic world is demanding.
Okay, so I want to talk about each one of these four markets real quickly, but let's start with the strategic shift. You said is, hey, the amount of volume of traffic is going up exponentially. Give us some stats on the volumes of traffic that are going up.
Yeah, so this is it's interesting because very recently, just a month ago, we published our AI impact on the WAN report, right? And it's the first of its kind. What we actually did is we didn't just look at third-party sources and so forth, but we actually ran measurements with sensors in some of our service provider customers to identify what does AI traffic look like on the internet today, right? How is it growing? What is the nature of traffic distribution and patterns? And this is a public report that we've shared, and there's some really interesting stats. First of all, we're starting from a very low base because inferencing is only now starting to take off, but the growth rate is phenomenal. We are seeing 10x year-over-year inferencing growth rates, and obviously at some point it's going to kind of slow down a little bit, but it's going to go on for quite a while.
I don't think it slows down because you've got about 0.1% of the world that's using agents right now.
Yes, for sure.
So you're only going to see that compound over time. It's not going to slow down.
You're right about that. Yeah. The slowdown will happen many years, and by that time it's going to be a significant portion of the overall traffic. And we haven't even started seeing AI in a lot of video yet. Right? Once that happens, we're going to see even more. But we are seeing this incredible growth rate in inferencing traffic, 10x year over year. Moreover, we characterized how does this traffic behave, right? Because now we have agents that are actually driving. And it's things like people using Codex or Claude Code and all of these capabilities, right? That's one of the big contributors to the AI traffic. And we found that agents actually generate 450% as much traffic as humans do when they perform web transactions. And that's simply because they can do things so fast. They need a lot more context to reason and so forth. So we see this clear sign. Moreover, there's some interesting characteristics about the traffic distribution itself. There's a lot more upload that happens with AI traffic instead of just
because
pure
your
download.
markdown files, your skills file, your memory file have to keep getting uploaded.
Exactly. You need to send it to your inferencing model,
right?
And then that needs to be processed as context, and then it needs to respond to it.
Right.
And then imagine, as we start looking ahead, we are already starting to see signs of physical AI with a lot more robots and 3D spatial sensing and so forth. That's going to introduce a lot more video in the mix.
Yeah.
So you'll have a lot more video upload as well to your closest inferencing location. A lot of it will happen on-prem, but some of it will go over a service provider's metro network into a local regional inferencing cloud and so forth. So upload is a lot more. Traffic tends to be a lot more distributed as well, in the sense that these agents, and imagine a world where you have millions, if not billions of agents, every enterprise application agentic enabled, every consumer application agentic enabled. All of these are talking to inferencing cloud endpoints. They don't just talk to one cloud location to download data as we might do today.
It's very chatty. It goes across multiple
very
different
chatty.
areas. Yeah.
So the net effect of all of this is that the network over which all of this is serviced, a service provider's network, needs to adapt significantly to handle that traffic load, to handle the multi-directionality of traffic. A lot of it will be latency sensitive. We don't think latency is going to be the only factor like everybody thought in the 5G age. But
basically, latency, performance, and power would be the three, right?
Those are going to be the three primary ones, absolutely.
So, Guru, one other question that comes up a lot is, especially in data center build-outs, is around energy efficiency. Because if you think about it, we just don't have enough power, compute, and network bandwidth in the world to satiate the needs of AI, and that's been a pretty commonly known fact at this point. We're doing a lot on making sure that these infrastructure elements are built in a sustainable way and that we actually have very, very high efficiency on power consumption. Talk to us a little bit about that. What's happening? What are you doing? And give us some stats.
So power has been probably the number one constraint when we talk about data center build-outs, right? Now we're starting to see some others, but power continues to be one of the key ones. And so the desire to build extremely power-efficient network infrastructure and compute infrastructure has been a very high priority for data center builders. So what we have done from our side is it begins from the silicon itself, right? Building extremely power-efficient silicon, and this is what we pride ourselves upon when we build Silicon One, making sure that the silicon itself is super power-efficient, but then also all of the software that goes on top of the silicon and the systems, the nature of systems we build. Because we are now building extremely high-capacity silicon, we have the ability to deliver in small fixed form factor boxes, 1, 2, 3 RU, that would earlier take big modular chassis to do, right? 50 terabits of routing and more. That's a huge difference because a chassis with all the fabric cards and line cards and everything,
the size matters on power consumption.
Big time. And it's 8, 9, 10 kilowatts for the chassis, and we can deliver that in less than a couple kilowatts when we talk about fixed systems. So there's a lot of innovation there. But that's not where it stops. That's actually only the start, because we have optics and optical that is being integrated more and more. One of the big things that we've been pushing for a couple of years, and now the entire industry has really started embracing it, is something we call routed optical networking. And that is this idea that you bring together IP and optical layers together. So we have coherent pluggables sitting in the routers, and that means you're eliminating an entire layer of hardware.
And coherent pluggables are the ones that go data center interconnect.
Correct.
And so you have these, rather than having the big transponders, you can just actually have a bunch of pluggables within your...
We can drive distances of hundreds and thousands of kilometers just with these little pluggables that sit inside the router. And so, it's 120 kilowatts in a transponder card versus 23 kilowatts is sitting in the router. Huge power savings when you put these coherent transponders in. So that architecture, and then more and more optical integration into our systems, is something that we are really focused on. And then additional things. Now we have already started building liquid-cooled systems, right? Highly efficient liquid-cooled systems in our 50T generation, 100T generation, and so forth. So there's been a huge amount of investment in just the core technology needed to support infrastructure build-out. And then for the likes of NeoClouds, sovereign cloud builders who also buy software from us, right? The software that's integrated on those systems, we have capabilities in our software as well for intelligent power optimization, fan control, all kinds of things designed to make sure that we keep the power profile, the real-time consumption of power as low as possible.
Right.
So this is just scratching the surface. There's a lot we're doing here.
And then this, I'm assuming that because the advanced packaging of the chips, where we also make our own SerDes and high-speed IP, that actually really helps with power efficiency as well.
Absolutely. So if you look at what goes inside a chip, you have the packet processors, you have the I/O, you have the SerDes, you have the buffers. So because we control the entire technology stack there, the packaging and the design, we can bake in power optimization and sustainability as a core characteristics of those designs.
That's great.
Yeah. And then there's a whole discussion around how can service providers be more effective participants in intelligent token delivery, not just over-the-top token delivery, right? So there's a lot of opportunities to rethink how network infrastructure behaves.
The way I try to talk to, way I think about the business that service providers are in, because a lot of times service providers will ask, hey, what do you think we should be doing?
Yeah.
I think you have to be in the path of token generation.
Absolutely.
And if you're just in the consumption point of token generation, it's marginally interesting. But if you're in the path of token generation, by the way, the amount of kind of infrastructure that they had laid out with 5G is actually, this might be the mechanism for them to go out and monetize all of that they haven't been able to fully.
A lot of the infrastructure, that's a very good point actually, because both great points. One, how can they be in the middle of token generation and intelligent token delivery and not just be providers of over-the-top tokens, but also the infrastructure to deliver all of this by definition is very distributed.
Right.
Because unlike training clouds, which are a few hyperscalers, big data centers, gigawatts, the inferencing ecosystem is all kilowatts and megawatts of capacity from a power perspective. And telcos have already built a very rich set of distributed locations, points of presence or POPs as they call them, where they have just the right amount of space, power, 20 megawatts is plenty, and the fiber to deliver all of this. So you're right that they can actually realize a lot of the
CapEx that has already been spent can actually be monetized.
Can actually be monetized now.
Okay, so now let's talk about Cisco and what Cisco can do to help. And let's talk about each one of the class of customers. Let's start with hyperscalers because they're the most sophisticated on the kind of things that they're doing at scale. And then we'll go hyperscalers, NeoClouds, sovereign clouds, and then service providers. So let's start with hyperscalers. Tell me why hyperscalers are coming to us. Tell me why we've actually gone from what was virtually for AI workloads almost zero in orders taken 3 years ago to we thought we were going to do 1 billion last year. We ended up doing 2.3.
Yes.
We thought we were going to double that this year at 5. We're going to end up doing close to 9. Why that level of surge and what is happening over there and why is Cisco uniquely differentiated?
A lot of credit to our engineering teams, to our sales teams, just a whole cross-functional set of teams for having pulled that off. But if you think about what hyperscalers are looking for, they build, first of all, technology is paramount. Making sure that you have innovative technology, leading technology. For example, they're looking for 50 terabits, 100 terabit switches beyond, advanced optical
One thing I've
capabilities.
actually told people is you should expect over the course of the next few years, we should have a 1 petabit switch with 1 trillion transistors.
It's not unrealistic.
Is it crazy?
It's not unrealistic at all because we are already in the 100T era. As you can imagine, we are working with our customers 2 or 3 generations beyond. So having the right ingredients for delivering technology, silicon, optics, liquid cooling, various kinds of optical packaging, right? NPO, CPO, XPO, all of these. We have all of those assets. We have our own in-house silicon with Cisco Silicon One, which has been a phenomenal investment, and it's really paying off now.
Started that a decade ago, and it seems like a genius move now. But I take no credit for it. But I think it was, you have to thank all the people that made that happen.
2 of the things that have worked out really well for us, Silicon One and then our Acacia acquisition gives us the capability to bring coherent optics technologies, not just pluggables, but a lot of those technologies are now coming together. Silicon and optics are coming together. So technology is a big piece of it. We have that. We are also able to build the kinds of systems that hyperscalers want, right? Because a lot of them want very bespoke systems. They co-design with you. So you need to have those skill sets and those abilities. We have that. So we're able to deliver that to them, right? They look for diversity of supply chain, of technology. We have that. Silicon One and our optics is something we build. We own the entire supply chain right down to, buying wafers from TSMC. So that is an advantage. We also engage very flexibly.
We're not just building ASICs. We have a full customer-owned tooling and customer-owned toolkit for, that goes direct to TSMC. So the hops to TSMC matter.
And that has huge value. And then of course, we engage with them on a variety of different business models. They buy chips from us, they buy systems from us. We give them software support for what they want, right? Some of them put Sonic, others put FBOSS. So we are able to engage with them in a variety of different ways. And so the combination of technology, the ability to engage the way they want us to engage, co-designing, the supply chain, right, not to be underestimated, the value of our supply chain, all of these factors together
and scale really matters on that dimension.
It is absolutely paramount because the order at which they consume systems is it's not something you need a really deep supply chain capability to be able to do that, and Cisco has that. So all of these have been very useful.
So what you're saying basically is one of the big advantages is you've got a technology stack that is a fully vertically integrated platform that's a co-designed full stack.
Yeah.
Everything from silicon and optics to systems hardware, systems software, and then on and on above that. That's a huge differentiator.
Yeah.
What else?
Engagement models, the ability to engage in a variety of different ways.
Yeah.
All right. Responsiveness, speed of operation is extremely important. We have seen technology cycles compress. A decade ago, we would release new silicon every 4 years, not just us, the entire industry. Now we are releasing new silicon every 18 months, right? And compressing even more. So hyperscalers need that kind of velocity. And then also looking forward, right, there are all these technology investments. It's a huge amount of investment, as you're well aware, Jeetu, we need to make in these spaces. And Cisco's willing to make that investment, going 3, 4, 5 and further, right? So all of these are critical.
So that's how you start with the hyperscalers. Clearly there's momentum over there. Let's go to NeoClouds and sovereign clouds.
Yeah.
Why should they think about Cisco, and what are they going to get from us that they don't get from elsewhere?
Yeah.
And by the way, silicon diversity is a big reason as well, because you don't want to get locked into just one provider. So you need to make sure that you have multitude of providers.
That is absolutely true.
Yeah. And there's only a handful of people that make silicon for the networking silicon side.
That's right. Yeah. And so, and Cisco, obviously now we have proven this, right? Having been in the most demanding hyperscaler environment. So we definitely have, I believe, earned our credibility that we can deliver these. NeoClouds, slightly different, right? NeoClouds look a lot of the time, some of them, the biggest ones, are looking for the same kinds of things that hyperscalers are.
Yep.
So we can meet them the same way.
Right.
But others...
And these tend to be co-design projects where it's almost semi-custom work that needs to get done. Because everyone has a different architecture, different roles that they need to go out and fulfill, so on and so forth.
Absolutely. And so we need to get engaged much earlier in the cycle with them, even as they are conceptualizing design. So we do that. And so it's with a few of these big ones, Frontier Labs and so forth, it's the very same kind of engagement model. But a large majority of the NeoClouds actually are looking for fully integrated solutions. They want the silicon systems, software even for us. They may not necessarily go with open source options. So they need a fully integrated stack, because for them, being able to monetize those GPUs they're buying ASAP is most critical. So they want the networking that just works, management for all of that. So we have the ability to do that. So with our Nexus portfolio, for example, we bring in the complete stack, including our Nexus dashboard, which is now being integrated as part of Cisco Cloud Control. And what's more, we also have partnered with the likes of NVIDIA, so we can make sure our networking technology and our switches and our fabric works really well with NVIDIA GPUs, right, with their NICs and so forth.
And Spectrum X.
We have Spectrum X support as well. For those who want that variety, we support both. So it's the key value they get from Cisco there is the ability to move from concept to implementation very, very fast, because we bring in the whole stack. And by the way, we connect these to our service provider portfolio as well, because if they're building WANs and data center interconnect as well, right? And that's a key topic we should talk about, because some of the technologies we are building, especially in data center interconnect and scale across use cases, we are uniquely ahead.
Let's talk about all those three, because there's scale up, scale out, scale across. On the scale up side, it's largely within the rack, and you have to make sure that you connect the GPUs within the rack. Scale out is when you do row level connectivity of multiple racks within a row.
That's right.
And we have special chips for that. So talk to us a little bit about how hyperscalers, NeoClouds, and sovereign clouds are thinking about that.
Yeah. So, the simplest way to think about it is, first, all these AI cloud providers and NeoClouds and hyperscalers, they try to maximize throughput inside of a rack, that's
Yep.
scale up. But you run out of capacity very fast because you can
Yep.
have 72, maybe more in the future, but not hundreds and thousands of GPUs inside a scale-up environment. So you need to interconnect them, and that's the scale-out that you refer to, right? We have switches typically connected in leaf spine configuration, so within a data center, typically.
Yep.
And so Cisco has our G-series silicon, and we build high-performance switches, 50 tera, 100 tera, more, with the right optical interconnects and so forth for that scale-out environment. But what's becoming interesting is, in some cases now, even the confines of a data center are too small to accommodate some of the large training workloads. So you need to actually connect data centers, often spread
Hundreds of
kilometers across, and run workloads across these two data centers. And so you
And
need...
we've built a separate chip for that.
We built a separate chip. Yes.
P-series chip.
And it's the P-series chip. And there's a reason why we built a separate chip. It's the same architecture. It's still Silicon One.
Yep.
But the P-series also has deep buffers. And that's critical because once you start going over long distances, there is higher possibility of jitter. There is sometimes you cannot control the traffic. If it's pure back-end traffic, maybe you can control it a little better. But if it's front-end traffic, you cannot control because there's multiple flows. There's a lot more variability.
Yep.
So the impact of dropping a packet is very, very high.
Yeah,
and so
you have to restart a training run.
We have to completely restart the training run. So it's very high. So shallow buffer switches don't actually work very well. In some very highly tailored applications, they do, granted. But in a lot of the applications where you need to go across, you need deep buffers. You need the ability to temporarily hold packets while the jitter clears and so forth. So you can guarantee a much higher overall throughput for your run, whether it's training or inferencing.
Okay, so you've now covered Neos and Hyperscalers.
Yeah.
Sovereign clouds is just a variant of NeoClouds, just with a nationalist agenda as well,
Correct.
because they need to make sure that they're optimized for the nation that they're in.
That's correct.
And so you think about companies like Humane, you think about companies like Jeep42. Those happen to be, great partners of ours.
Right.
Walk us through now on the service provider side.
Yeah.
What has changed in the way that our technology is not just perceived but implemented within service providers? And what are the major things that, if you were to tell service providers, here's what you should know about Cisco, this is what it would be, what would that be?
Very good question. So we, 2 years plus ago, when we had the ChatGPT moment, we began thinking really hard about how do we make sure we build AI-ready infrastructure for a service provider? What does that mean? And so what that has resulted in is an entirely new portfolio that we've built from the ground up, Cisco Silicon One based, but we have a new line of chips just for our service providers. These chips have embedded capabilities, telemetry, sensors, etc., specifically designed to identify AI traffic, characterize it, and so forth. So what this has allowed us to do is, and it's not just the chips, we've built the right systems on top of it, the management, and so forth. But what this allows us to do in terms of outcomes is three things, right? First, for service providers, they can now actually make what I would say intelligent AI fabrics, not just pipes and networks that connect endpoints, right? So they can get visibility into the AI traffic that's flowing through the network. They can make decisions on that AI traffic. They can slice AI versus non-AI, create different kinds of low latency, high performance slices that they can monetize by selling to enterprises that are sensitive to those kinds of traffic patterns and so forth. So they can actually take a lot more intelligent decisions based on the AI traffic that's flowing through the network, right? To your point, be part of the token generation and not just carry it over the top.
Right.
We've also done some interesting things. For example, if service providers now, if you imagine a world where you'll have these millions of agents, these agents need to talk to inferencing clouds. Right. Someone needs to tell these agents which inferencing cloud to go to.
So you need some kind of intelligent routing technology on that front.
Exactly. So if you think about, the closest proxy I can think about is DNS, right? Domain name servers, where when humans type a name, it gets translated to an IP address.
Right.
Someone's determining where that should go to.
Right.
These billions of agents will need similar kinds of capabilities because you need to be able to provide cheap tokens, high-performance tokens, complex reasoning tokens, and so forth.
You need to know which model to go to, which is going to be the most fit model for the prompt that you've actually posted.
Exactly. So you need a proxy function, and service providers can provide that. So we are bringing in capabilities like that allow them to be very much part of that intelligent token delivery. So that's one of the things, and there's a lot more we're doing there, but just to give you that example. Then the other thing that service providers can do is actually leverage that infrastructure you talked about where they built things out during the 5G era.
Right.
They can actually repurpose a lot of those physical assets, power, fiber, to actually host inferencing clouds because they have the natural advantages already. In fact, if you look at so many NeoClouds, that's exactly the market they're trying to get into. Set up these data centers so they can provide inferencing. Well, service providers already have natural advantages that they can capitalize on. So we've built an entire stack. So our Nexus-based secure AI factory, everything we talked about earlier, right, with the right management inside the data center, connected to the AI fabric, we have that full end-to-end solution. It's a value they get from Cisco that they would otherwise have to, engage multiple parties to plumb together.
So what would the service provider have as an objection on why not to work with Cisco?
Honestly, I can't think of any at this point in time, Jeetu, because I think if you look back 5 years ago, 4 years ago even, we didn't have the right technology blocks. Now we have the silicon, we have the systems, we have
was
the
missing
complete stack.
4 years ago?
So, I think our existing platforms were getting to be legacy. We didn't have the latest, but now we fixed that. We have Edge, Access, Core, an entirely new portfolio. It's getting to be very feature-rich. We have an agentic ops suite, which is a very important component of all of this that's getting integrated into Cisco Cloud Control.
Cisco Cloud Control is the unified management plane for those that don't know.
Right.
That can actually have every single technology we have is now going to be accessible through that.
So you can do multi-domain management. You can
And
bring in
troubleshooting
security and
and debugging and
troubleshooting,
all that.
observability, all part of a unified ecosystem. So we have that, right? And then the other thing we've done is we've actually brought, and you like to talk about this, the platform effect, right? So we've brought all of these capabilities together across our different pieces of the Cisco portfolio, integrated security into our infrastructure, right? Security has become a huge thing. Being able to react very fast to vulnerabilities. There's a functionality called Live Protect that we've been talking about, which allows you to apply compensating controls really quickly and improve the security posture dramatically. Things like that we have introduced into the infrastructure, and we have reference architectures now that can connect our enterprise solutions, SD-WAN and others, to our service provider intelligent AI-ready networking into our data centers. So our customers can get the full stack end-to-end from Cisco. Again, it's something that is very hard to plumb if you are doing it piecemeal, right?
Yeah.
So these are the kinds of things that we have today that we didn't have just 2 years ago.
So what questions do you think am I not asking that should be getting asked so that the world actually has a view that's congruent with the level of innovation that you folks have done?
We went through a lot, but I think the one thing that I see with the service provider community in particular is I think they are underestimating how much opportunity they have.
Yeah.
And so just the education of what Cisco brings to the table, all of these things we talked about, a full portfolio for the AI economy, helping them be a big part of the token economy, that is what I think our service provider customers are perhaps not asking enough. Some of the big ones are now, and we are partnering very closely with them. But a lot of them are only now becoming aware of what they can do and how they can be a big part of the AI ecosystem.
I would say there's probably another area that we're going to need to have many, many more conversations. There's a lot of conversations that have started, but we are living in a post-Mythos world.
Yeah.
I think there's a lot of aged assets in service providers.
Yes.
End of life, end of support. These can cause a fair amount of risk, and we need to make sure that we're actually working and partnering with our service providers to make sure that it's not financially prohibitive, but not also something that poses risk at a national level because there's dated, aged infrastructure that's not actually that's being sweated out for a few more years. So.
That has become a huge topic now with Mythos being released. I just came back from our New York service provider customer advisory board where we had 30 of our customers, right? Tier 1 telcos, regional telcos, enterprises, education networks, pretty diverse group. This was one of the key topics on how do we make sure that we can actually start start moving faster in terms of plugging security gaps in our network, but also figuring out how we deal with legacy infrastructure, because that is one of the biggest access points for the bad guys. So, and we have a bunch of solutions there that we are working through.
Well, Guru, thank you for everything that you're doing, my friend. And I have to say that the progress that's been made just in the past 2 years since you and I have started working closely together, I've been blown away. And we're lucky to have you. And I can't even wait to see what the next 5 to 10 years hold. So,
thank you, Jeetu. I echo that sentiment. Thanks for all the support.
Thanks.
Yeah.